Hey guys, yesterday you learned about incomplete and codominance, which are two types of dominance. Previously, we had learned about complete dominance, so we're shifting gears a little bit. Today, we're going to learn how to do Punnett squares. So we're going to have a quick review. Then there's a couple slides you need to take notes on and a couple examples, and then you're going to practice a couple times. I'll let you know what I want you to write down as we go. All right, so remember that incomplete dominance is when the alleles are both partially dominant. So neither one is fully dominant. So that results in a blended trait when you have one of each. So the example we used yesterday was a red flower and a white flower. And when you have a heterozygous offspring, it is pink. Now in codominance, both alleles are fully dominant, and so they're fully expressed, or both are completely visible at the same time. So in the bottom example, you have a red flower and a white flower, and their heterozygous offspring would be red and white striped or spotted. So you can see in that picture that you can see both red and white at the same time. That means they're fully dominant and being fully expressed. Whereas in incomplete dominance, you don't see that. They're blended together. So neither one is totally dominant. So you get a blended trait. All right, this is a slide that I want you to write the information down. You may want to pause after I finish going over the information. So we are going to learn how to do Punnett squares. And the process is pretty much the same as what we've been doing with two small changes. So first of all, we represent the alleles with different letters. So up until this point, we've used capital and lowercase letters. And we're going to switch gears a little bit. So that's how you do complete dominance. For incomplete and codominance, you use different letters. So instead of like a capital B and a lowercase b, you would use like a capital B and a capital W. They're both dominant, so you'd use capital letters. And then we always use capital letters. I just said that. So since they are both dominant, we represent it both by a capital letter. All right, so my example here, I have the black allele represented with a capital B and the white allele represented with a capital W. So if you have an organism that is BB, that would be black. If you have an organism that is WW, that would be white. And if you have a heterozygous organism that was BW, for incomplete dominance, it would be gray. For codominance, it would be black and white striped or spotted. Again, write down the information on this slide. All right, we're going to go over a few examples. I do want you to put each of these examples in your notes so you have it to refer back to. So you don't have to write down the problem, but I want you to copy the Punnett square that I do. So we're going to look at incomplete dominance first. So in this example, we're looking at some mice, and their coats can be yellow or white, okay? And if it's heterozygous, it could be capital W, capital Y. So we're going to take two cream-colored mice, which are heterozygous, and determine the percentage of each phenotype that we would expect. So they're both heterozygous, so we're going to use YW for both of them. So I'm going to set my Punnett square up and put YW above and YW to the left. Now, just like a normal Punnett squares, we're going to distribute those letters. So in the top left, I have a Y that's above and a Y that's to the left. And then on the top right, I have a capital that's above and a Y that's to the left. On the bottom left, I have a Y that is above and a W to the left. And finally, for the last one, I have WW. All right, so we figured that all out. Now we need to figure out the phenotype of each. So the yellow ones, remember, are going to be YY. So I look in those boxes and I only see one that is YY. So that is 25%. Then for white, it has to be WW. And so in the bottom right is the only square, so that is also 25%. And then in order to be cream colored, it has to be YW. So I see that the top right and the bottom left are YW. So each box is worth 25%, so that's going to be 50%. All right, let's go on to an example of codominance. So in some chickens, the gene for feather color is controlled by codominance. The allele for black is B, and the allele for white is W. The heterozygous phenotype is known as Punnett, which means black and white spotted. You can see a picture on the top right. A black chicken and a white chicken are crossed. Okay, so we are going to figure out the probability of each phenotype. So it says a black and a white. So the black is going to be 2 B's and the white is going to be 2 W's. It doesn't matter which way you arrange them. I usually put, if I don't know which is male and female, I put the first one listed on the top and the second one listed on the left. You would normally put the male on the top and the female on the left. All right, so then I'm going to distribute my letters. So I'm going to do this a little bit differently this time. This is another way to distribute letters. In this left column, I have a B, so I'm going to distribute it to the 2 columns below. So I'm going to put a B there and a B there. And then in the second column to the right, I have another B, and so I'm going to distribute that in the 2 boxes below it. Okay, and then I'm going to do my rows. So I see the first row has a capital W, so I'm going to put a W in each of those rows. And then the bottom row is also W, so I'm going to put a W in those. Okay, so we can see that every single one is BW. And since this is since this is codominance, they're both going to be expressed. So we will have an 100% Punnett birds. All right, I'm going to move on to some practice problems.